we're going to continue with order of operations on algebraic expressions. So I've got two problems written up here. But before we start, I want to remind you the order of operations is do this stuff inside of the parentheses. Oops, let's move that up a little bit higher than my head. In fact, we're going to get fancy and change colors. I think the green is nice. Okay, here we go. We're going to do the stuff in parentheses, then we're going to do the exponents, then we're going to do a multiplication and division left to right, and then we're going to do addition, subtraction left to right. Here we go. Now, is there anything to do inside of these parentheses? No, because those are not like terms. So is there any exponents? No, there's no exponents. Now, multiplication and division. Okay, this is the tricky part right here. This multiply is right here. And you are multiplying -4 times everything inside there. So if I hide this right here, then what do I have? -4 times 4x. Okay, this is the distributive property of multiplication. Here and here. Okay, this -4w carries down. There's no work to do on that one. Now, this 4 times this 4 is -16x. Remember, you don't need like terms to multiply. Now, negative times a negative is a positive 28w. And I'm going to put an exclamation point right here. Exclamation point. This is that exclamation, well, that didn't show for you guys. All right, let's try this again. This exclamation point's right there. The exclamation point means, hey, be careful, that right there, that's the most common mistake. Students get the negative on this one, but then when they distribute the other one, they somehow just sort of lose it. And I'm going to carry down the 4x. Okay, now what are we left with? We're left with combining like terms. Multiplication and division is done, and I have addition, subtraction left to do. Okay, I'm going to use color, underlining the like terms. I'm going to rearrange the problem to where those w's are right next to each other and those x's are right next to each other. So here's the problem. -4, let me move to the side, w plus 28w, that's those two. And then I'm going to have subtract 16x plus 4x. Now what I did right there is I used the commutative property of addition. And that says that if you add two things or more than two things, it doesn't matter what order you add them in. So what I did here that was a little bit different is I glued that subtraction sign to the negative, to the 16, and I think of it as a -16. So what was a subtract sign is really now, you think of it as a negative. Okay, that kind of weird. Now we've got addition, subtraction of like terms, and this problem just proceeds now as you would think. 28 take away 4 is 24 of them, and -16 plus 4, think of that thermometer where you're at down 16, then you move up 4, you're still pretty cold if you're doing degrees, but there you have it, you're at -12. Okay, now this problem, let's come over here. We're adding like terms, so order of operations applies, but is there any parentheses? No. Are there any exponents? Well, yeah, but I don't have to actually square anything. It's already squared. Is there any multiplication, division? No, because it's add, add, subtract, subtract. Now, addition, subtraction, left to right. Okay, but I need to do the like terms. Like terms, like terms. Really, this problem is much like this one at this step. Here we go. I'm going to underline them. Let's do the same thing. We'll use pink. Okay, I'm going to show this step on my work, and this is what I would expect you to do. Give me something to grade. Okay, this problem doesn't have a lot of work, but at least show me that you know that those two go together. Now, let's do these. No, actually, I don't want to do that one next. I want to do this one. There's only one term with an X, so I'm just going to put it right there. Now, let's see, what do I have? Pink, green, let's grab blue, and I've got this one. And I think my screen's running out, but I'll just sneak it in here. Plus 5 minus 10. We're okay. All right, now these two are like, they go together. I'm at down 2, up 17, that puts me at up 15. you see how I do that? I'm constantly thinking of this as a number line or a thermometer. Okay, now this one, there's no other term, so just write it down. And these two, those are like, again, you're at 5, take away 10. Think of that number line here. If I can write this in front of me, this is, you're up 5 and you're gonna take away 10. Where do you end up? You end up at -5. Okay, this is called descending order. The squared is the highest power, and then you descend down to a power of 1, and then a subtlety here is this actually doesn't look like it has a variable, but you could put x to the 0 because anything to the 0 power is 1. So this is descending, 2, 1, x to the 0, but we don't write the x to the 0, and you also don't write the 1. Okay, you'll be good for this one.